modules in one class. Okay, so this one is troubleshooting static and default routes. In chapter 15, we looked at static route, different categories of static routes and how we can configure them. And in this chapter, we're going to be looking at how we can troubleshoot them. This is a fairly simple chapter. I've got only 17 slides on this one. So it's an easy one. Okay, in terms of objectives, we got two main objectives. First one is to explain how the router processes packets when a static route is configured. We're going to look at that one. And then the second objective is to troubleshoot common static and default route configuration issues. Okay, we're going to look at those issues as well. So now, starting with the packet processing with the static routes. Okay, here we go. Example topology. You can see on your screen. It's over here. Okay, in this topology, you got three routers: R1, R2, R3, and you got three networks as well. You got network 1 is over here, 10.172.16.10. Then you got then you got 2.0 as well, then you got 3.0 network. Okay, and on the other side you got the network starting with 192.168.10 and 192.168.20 network. You got three PCs, PC1 connected to 16.3.0 network, and PC2 connected to 1.0 network, and finally you got PC3 connected to 192.168.20 network. Okay, in this scenario, the PC1 is trying to send a message to PC3. Okay, from this topology, as you can see, the message will go from it will take this route. It will go to your router. Then router 1 should send it to R2, and then R2 will forward this message to R3. Then R3 finally send it to PC3. Okay, the reason is we do not have any direct connection between R1 and R3. That's why we have to go through R2 to deliver this message to PC3. Now we're gonna look at how in the more detail how the whole process works. Okay, and what if scenarios. So the first one is PC1 addresses the packet to PC3, okay, and send it to the default gateways. Now it's very important to understand these terminologies. Default gateways in this case is R1. So okay, this is a router which is to whom all these computers in one network are connected to. And this is the one who's connecting all these computers in this network to the outside world. Okay, so that particular router is known as a default gateway. Okay, so now the PC1 will send the message to R1. It will have an address of PC3. So when the packet arrives at R1 on the interface G00, okay, and what it will do, it will de-encapsulate the packet. What it means, it will unwrap the packet to look for the information. So what he's gonna look for? It's gonna look for the destination address or network entry address. Okay, and then he's gonna match that destination address with the routing table entries in R1. Okay, now there could be three scenarios when he's searching for a matching network address in the network table, in the routing table. One possible option could be it matches a static route entry. Okay, in this case, R1 will use the static route to identify the next hop IP address or exit interface. The second scenario could be it doesn't match any specific route to the destination network, and in this scenario, it will use the default static route if that is configured on R1. Okay, and the third scenario could be it doesn't match any of the entry, and it will simply drop that message and send an ICMP message back to the source, which is PC1. ICMP is one of the internet protocol which is used by routers for error reporting. For example, if the router cannot find any matching address, then it will send a ICMP message back to the source. In this case, it's a PC1, saying that it could not find couldn't find the destination address, and it has dropped the message. Or if there is any other issues, then it will use the ICMP message to inform the sender. Okay, so these are the three scenarios. This is what's going to happen at R1 level. Now we're going to assume that the R1 has found an entry, okay, in the routing table, and then that entry belongs to R2, so it will simply send that message to R2 on the interface S010. Okay, once the R2 receive this message on S010 interface, it will perform the same sort of activity as R1 did. So first of all, it will de-encapsulate the packet. Okay, it will then find the matching routing table entries in R2 table. Okay, and once you found it, and then it will send it to the next hop routing address. So in this case, it's R3. Okay. Now, once you send it to R3 gonna do the same thing again. It's gonna de-encapsulate the packet, and it will again search for the routing table for a matching address. Okay. Now, in this case, R3 will find out that yes, it has the matching address in the routing tables, and this is a directly connected computer or device. So in this case is is PC3. Okay, so what he gonna do now, because it's a directly connected device, and for these sort of devices we use their MAC address to send that message to that particular device. Okay, now as you know, each device got something called ARP table. Okay, ARP table that contain the MAC address and also the IP addresses. Okay, it's this kind of mapping table, which is where you got the IP addresses and also matching MAC addresses. Now, if now the R3 gonna now look for the matching MAC address in that table. If you couldn't find it, then it will send a ARP request to to this network over here, and the PC3 will receive that ARP request and reply back to that request with his MAC address. Then the R3 gonna use that MAC address and forward the message to PC3. Okay, so this is how the whole process works. Any question on this one, guys? So you think it's clear the whole process, how the whole thing works? Brilliant. So this is it. So that's your part one done. Okay, that was understanding how the messages get processed over the network, how it's traveled from one computer to another computer. I will just go through one more time to this one. Okay, so over here again, one more time, the PC1 is gonna send a message to PC3. It will go to the default gateway address, which is R1. R1 will de-encapsulate the packet, look for destination address and matching entry into the routing table. If it's found it, then it will send it to the next hop IP address, which is R2 in this case. R2 will perform the same activity as R1, de-encapsulation, matching of destination address, then again forwarding it to the next hop IP address if there is one. Okay, and then on the next hop IP address is going to do the same thing. It's going to de-encapsulate, do the matching, and in this case, if it's a connected device, then it's going to look into ARP table for the MAC address. If there is no entry in the ARP table, then it's going to send an ARP request. Okay, and then the PC3 gonna receive that ARP request. It's gonna reply back to R3 with this MAC address. Okay, and then R3 gonna update his ARP table and then forward that packet to PC3 using his MAC address. So that's how the packet get processed. Now our section number 2, troubleshooting IPv4 static and default route configuration. Right. So this is also a very important one because as a network engineer you will come across such situation where the network will fail, and there are a number of reasons for network failure. Okay, the first reason could be the interface can fail. Okay, the interface is it could be the issues related to your wire is not connected properly, or or the wire was disconnected, or it could be a service provider drop a connection. So it will be the issue at the server's ISP end. Maybe they have some sort of technical issues. In this case, you can't really do much. Obviously, you have to open a ticket with your service provider, and report a fault to them, so that they can resolve at their end. And the next one could be the link can become oversaturated. This could be another issue that can have a network failure. Then finally, you can have an administrator may enter wrong information. This can happen. It's a human error, and as a network engineer, you should be able to investigate this one. We have a number of commands that we use to check the wrong configuration, and this is what we're going to be doing this time as well. Okay, so let's look at some of the commands. These are the most popular command that you will be using to investigate a network failure, and especially when it comes to wrong information entered by an administrator, or loose end, or there's a wire disconnected. You can get that information from using these commands. Ping command is the first one. You're already familiar with this one. This is to verify layer 3 connectivity between two devices. And then you go a trace route, which verify the path to a destination. It's quite useful. It gives you the information about where the problem is. So and where you're basically in the ping command, you will only get like whether your connection is successful or it's failed. With the trace route, you can actually see where the connection failed, at which particular stage over the network route the connection failed. So trace route is quite useful. Then you got something called show IP route. It's very useful. It displays you the routing table. So as you know, we can specify static and default route in the routing table. So as a human, we can make a mistake in defining these routes. So if there's such issue, then you can check it out with the show IP route command. Then you got something called show IP interface brief. This command will help you with your first issue, which is called interface can fail. So if there's an issue with the interface failure, then you can check it with the show IP interface brief command. This will give you a list of a table, okay, with the list of all the interface on that particular device. Okay, then you can check with their status as well, and you can check their status whether they are up and down or whether they are administratively down, because sometime as a network engineer you can turn down a particular interface for ABC reason. It could be a security related, or maybe it was not used before and it is, so that's why you turn it down. So you can use this command show IP interface brief to check the status of all the interface on your device. The last one is called show CDP neighbors. This is called CDP means Cisco Discovery Protocol. So this is one of the command that display a list of directly connected Cisco devices. So it's all provide you the information about the Cisco device, not any other ones. So CDP neighbors. So this is again useful because then you can see whether you can actually discover the other Cisco devices which are connected to that device. Okay, this is one of the scenario over here. We can see we have issues between pinging from R1, or let's say PC1 to PC3, and you got the routing table over here, okay, of R2, and initially what happens is R2 was able to ping R2. Sorry, R1 was able to ping R2, and then R2 was also able to ping R3. but R1 was not able to ping R3, P3, PC3. So then they looked, obviously, like if this connection is working, if R1 is able to ping R2 and R2 is able to ping R3, then it should be, technically, it should be able to ping. This message should be able to go to this router, and then this router should be able to deliver this message to PC3 without an issue. Okay, then and then by looking into the routing table, especially on R2, this is the routing table entries you can see over here, and we discover a static route which was configured incorrectly. Okay, you can see there's a network address which is 172.16.3.0, which is address over here. Okay, and they said in this routing table, in the R2 entry, it says you can reach this network via this interface. Now this interface is over here, you can see. So you cannot reach this network via this interface. You can only reach this this network via this interface. So this is where the problem was. When you try to ping, let's say, the message from this PC3 from R1, and the message was going to this to this R2. R2 was delivering to our PC3, but it was not able to get the reply back, because whenever a PC3 tried to send a reply back, it was basically sending to R3. R3 was sending to R2. When R2 tried to send a message to this network over here, it was using this particular network or this particular interface, and this reply was going back to this network again. So that's why the problem was. And now you can resolve this problem by simply correcting this entry. As you know, as we discussed in chapter 15, to set up the static route, first of all, you should remove this address. Okay, and by simply using no IP route command, and then install a new route. And to install a new static route, the command is simply IP route, the network address, the subnet mask, and the interface or the IP address through which you can reach this network. In this case, this is the one. Okay, you guys, you think it's clear the problem and how we resolve it? Brilliant. You're gonna be using right. You're gonna be using this one in your final exam. There will be some the questions regarding IP routes, how to set up the IP routes. Okay, so this command is really it's very important, and it's very important to understand how we come up with this particular line of code. So you have a IP route, which is obviously is a syntax. Then you got this network address, which is just over here, and then you got this subnet mask, which means it says 255.255.255.0, which means it's 24-bit address. That's why you got 88824 and then 0. And this is the interface through which you can reach this particular network. And this one is over here. And you can see 172.16.2.0. This is the network, and this is .1. This is the IP address of this interface through which the R2 can send a message or forward a message to any device over this network. That's why we call 172.16.2.1. Right, that's the end for this chapter. As I mentioned, this is quite small chapter. You got some practice quizzes as well. I would recommend you guys go through this one. And you got one packet tracer activity that you may want to go through, is troubleshooting IP4 static route, the one that we just did, and also how to configure the static routes and the default routes. So it's quite useful. You can go through this one. Again, you got the lab activity as well, that about troubleshooting static and default route again. And again, what we have learned on this one And this module host send a packet to another host and send it to the default gateway address, which is the router address. And when the packet arrives at the router interface, it de-encapsulates the packet and search the routing table for the matching destination entry. And again, there could be a several scenarios. What will happen if it matches? What happens? What if it doesn't match the specific route? And what action the router will take, and so forth. We also looked at the same process happen uh, throughout the network. All the router perform the same sort of a process. They de-encapsulate the packet, look for the destination address and matching address in the routing table, and once they found it, and then they forward the packet. Okay, we also looked at the op table as well, which is at the final router. Once he received the packet, then he looks for op entry in the op table, which is basically is looking for a MAC address. If he can't find it, then it will send a op request to the network, and once he got it, then he will use the MAC address to send over that particular packet. And then you have some commands like ping, trace route, IP route, IP interface brief, CDP neighbors to get more information about the issue that you're having on your network. Okay, that's it for now. I will